the quotient rule for derivatives. Let y equal f of x over g of x. Then its derivative, dy dx, is not f prime over g prime, but is instead the following. If you were watching the product rule video that I did, you'll know that I do derivatives not necessarily by letter or by formula, but by position. So here's how I do a quotient rule. When I say bottom and top, I'm referring to the original bottom and original top. So I start by squaring the bottom, giving me g of x squared. Then I bring that bottom up, the original, leave it alone times the derivative of the top, minus, I leave the top alone, times the derivative of the bottom. So this is the quotient rule for derivatives. I will not do the proof of this. It gets a little bit messy, and you can find a proof in just about any calculus textbook in case you need one. Let's take a look at y equals sine x over x. We want to find its derivative, dy dx. So I will start by squaring the bottom, and then I'll bring that bottom up, leave it alone, times the derivative of the top. So the derivative of sine x is cosine x, and then minus, I'll leave the top alone, sine of x, times the derivative of the bottom, or the derivative of x, which is 1. And that is how we do the quotient rule. Let's do a few more examples just to get some practice on this. Consider y equals 2x plus 3 over x minus 1. And let's find not only the derivative dy dx, but also the second derivative, just to see how we approach something like this. When we find the derivative, we're going to do the quotient rule. So I'll get it set up. We're going to start by squaring the bottom. Then we'll bring that bottom up, leave it alone, times the derivative of the top, which is just 2, minus, leave the top alone, times the derivative of the bottom part, which is simply 1. And if I was only finding dy dx, I would stop here. But since I'm going to find the second derivative as well, I'm going to clean this up and see if I can simplify it. So let's multiply the top out. We get 2x minus 2, and then minus quantity 2x plus 3, or minus 2x minus 3, if we distribute the negative sign, over x minus 1 squared. The 2x minus 2x cancels, leaving us with negative 5 over x minus 1 squared. Now this is a quotient, so we could do the quotient rule, but I prefer to do the simplest rule whenever I'm doing derivatives, which means I'm going to rewrite my derivative as negative 5 times x minus 1 to the negative 2. So instead of doing a quotient rule, and instead of doing a product rule, I have a number that is a constant times my function. So we're going to use the constant rule here, along with the power rule. That'll be the easiest way in this problem to find the second derivative. So recall that this notation, d squared y over dx squared, does not mean we're squaring anything, but instead we're finding the derivative with respect to x of the first derivative. And using the constant and power rules, we get negative 5 times negative 2, and then we subtract 1 to get the new power. Cleaning it up, we get 10 over x minus 1 cubed. Now consider the function h of x equals the square root of x over x squared minus 3. And we want to find the instantaneous rate of change. Of y, of course. That is y equals h of x. At, let's say, x equals 1. The instantaneous rate of change is the slope of the tangent line, or the derivative. So we will find h prime of x, which will be a quotient rule. Get it set up, and we will square the bottom. Then we'll bring that original bottom up, leave it alone, times the derivative of the top part, which is 1 over 2 root x. Just a reminder that the derivative of the square root of x is the derivative of x to the 1/2, which gives us 1/2 x to the negative 1/2. But I've done it so many times that I just write it like that. Let's finish off our quotient rule. So minus, now we'll leave the original top alone, times the derivative of x squared minus 3, that is the bottom part, times 2x. And perhaps we could simplify this, but since I'm plugging in a value, we're going to find h prime of 1. Let's see if we can just plug it in here. I get 1 squared minus 3, or negative 2. Then we get 1 over 2 minus 1 times 2. And then 1 squared minus 3, so negative 2 all squared gives us 4. Let's see if we can simplify this a little bit more. We get negative 1 minus 2 over 4, or negative 3/4. Let's do one more problem. Let's do a numeric example. So I'll get it set up here for you. And we're going to look at x equals 3. Give you some more information about, say, f of x, f prime, g and g prime. And without stating, at least officially, let's assume that f and g are continuously differentiable for all x. That just allows me to do the problem of technicality here, because I'm only giving you some values at one point. And let's write the equation of the tangent line. Equation of tangent line. And let's say to the function y equals g of x over f of x. And I'm going to put a little of there just because it was bothering me. And we'll do this at the point x equals 3, of course. That's the only x value that I gave you. Notice what I did over here. It's one of my favorite things to do when I'm teaching quotient rule, because I give you the formula f over g, but now I'm giving y as g over f, because it's not about the letters or the formula, it's about position. Okay, the equation of a tangent line, we need three things. We need the x, we need the y, we need the slope. Let's find the y value. Y is g over f, so it's g of 3 over f of 3. And we can find it just by looking in our table. We get 3 over negative 2, or negative 3/2. And now we need the derivative. At x equals 3. I'll put it there now. Recall that that vertical line here means evaluate at x equals 3. And let's get this set up. So the derivative with the quotient rule says, let's start by squaring the bottom, that is the original bottom. So f of x, but f of 3 squared. And then we'll bring the bottom up, so f of 3 times the derivative of the top, g prime of 3, minus, now we'll leave the top alone, so g of 3 times the derivative of the original bottom, f prime, and then at 3. And we'll plug some numbers in. We get f of 3 is -2 times g prime of 3, -1, minus g of 3 times f prime of 3 over f of 3 all squared, so 4 down there. Then we get 2 minus 12 over 4, which is -10 over 4, or -5/2. So we have the point 3, -3/2. We have the slope, -5/2. And we can write the tangent line now, giving us y minus the y value, equals the slope times x minus the x value.